Okay, I forgot that I gave out my last study guide, so I actually don't have a copy. But I do know one of the problems was this. So I'm going to do one rational function, one exponential, and then I'll just pick some random trig graphs to do. So the first one I'm going to do is I'm going to graph r of x is equal to x squared minus x minus 2, and then x squared minus x minus 12. This is one of the problems in your study guide. So I'm going to factor this, and this is going to become x minus 2, x plus 1. And then on the bottom, this becomes x minus 4, x plus 3. Note that nothing cancels out, so that's your rational function. Your domain is all x such that x cannot equal -3 and x cannot equal 4, since that is that's when the denominator is equal to 0. Now, my my y-intercept is when x is equal to 0. So I know when x is equal to 0, I'm left with -2 over -12, okay, which reduces to 1/6. So 1/6 is my y-intercept. And then I know my x-intercept is when the numerator is equal to 0. So this is the numerator factored. So I know I'm going to have x-intercepts at x is equal to 2 and x is equal to -1. Okay. I also know that I have vertical asymptotes at 4 and -3 because that is this is the simplified version. So that is going to be my vertical asymptotes. I'm going to have two of them at x is equal to 4 and x is equal to -3. My horizontal asymptote, since the degrees are the same, I'm just going to go ahead and take the coefficients and divide them. So I have 1 divided by 1. So my horizontal asymptote is y is equal to 1. Now what I'm going to do is I'm going to see, does my graph intersect the horizontal asymptote? So I am going to do 1 is equal to x squared minus x minus 2 over x squared minus x minus 12. When I solve this, I'm going to multiply both sides by x squared minus x minus 12, and this becomes x squared minus x minus 12 is equal to x squared minus x minus 2. The x squares cancel, the x's cancel, and I'm left with -12 is equal to -2, which doesn't make sense, so we are not going to intersect the horizontal asymptote. Okay? So that's all of the properties we know. Now let's go ahead and graph this. Okay. So let's go ahead and graph what we know. Oh, I shouldn't have erased that. But I know that I have vertical asymptotes at -3. I know I have a vertical asymptote at 4. I know my horizontal asymptote is at y is equal to 1. Okay. I know I have a y-intercept at 1/6, so it's going to be like right here. I know I have x-intercepts at 2 and at -1. Okay, so you could already kind of see the shape that it's going to form. It's going to form like a little parabola here on the bottom sector. Now, all we need to do is we could just go ahead and test the point. So I'm going to test, I'm going to plug in 5, okay? Now, I could plug in 5. I think it's easier to plug in 5 here instead of the original. So this becomes 5 minus 2 is 3, 5 plus 1 is 6, 5 minus 4 is 1, and 5 plus 3 is 8. That gives me 18 over 8. Okay, and 18 over 8 is around 2 1/4. Okay, so I know at 5 I am going to be around here. So I know my graph is going to go like this here. I know that I have an odd multiplicity, so I know I'm going to be down here. And it makes sense since my points, my x-intercepts and my y-intercepts are right there. So I know I'm going to go through here, come up, go through the points, and come down. And then since this is odd multiplicity, I know that this is going to go up this way, and this is going to be an asymptote. Okay. So your graph should look like that for this question. Okay. Now let's move on to the exponential that we didn't do in class. So the exponential is f of x is equal to -3 1/2 x plus 3. Now, like I said, in class, if you don't know what this looks like, just start with 1/2 x. Okay? And then if I plug something, if I plug -1 in, this becomes 2. If I plug in 0, it becomes 1. And if I plug in 1, it becomes 1/2. Okay? And now I can even go further, and if I put in -2, I know that I'll be at 4. So what I'm going to do is I'm going to graph this, and I know there's going to be a lot of transformations for this one. Okay? I know that it's going to be shift to the left 3. I know that it's going to have a vertical stretch of 3. And the last thing that I know is I know that it's going to be reflected across x-axis. So 3 transformations. I don't know if you could see that, but okay. So I know my original function. I'm going to graph my original one as -1, 2, 0, 1, and 1, 1/2. And let's just go ahead and graph the other point, -2, 4. So I know my original function goes this way. Okay? Now, however, I know I'm going to shift left 3, vertical stretch of 3, and reflect it across the x-axis. Now, if that's a lot of steps for you to do for one point, you should do each one step by step. So for example, if I have the point, let's do -1, 2. Okay? If I'm going to shift this to the left 3, I know it's going to be -4, 2. If it's a vertical stretch of 3, this is going to become -4, 6. And if I reflect across the x-axis, I'm going to make my y negative. So this becomes -4, -6. So my new point is going to be at -4, -6. So go ahead and do that with your other points. 0, 1. Okay. What happens to 0, 1? I'm going to move it to the left 3. That becomes -3, 1. I'm going to stretch the y value by 3, so this becomes -3, 3. And it's reflected across the x-axis. This becomes -3, -3. So I know I have another point at -3, -3. Okay. And thus this one, 1, 1/2. If I move it to the left 3, I'm going to go 1, 2, 3. I'm going to multiply it by the y value by 3, so it becomes 3 halves, and I'm going to reflect it across the axis, so I know this is going to be right here. So I know my graph is going to look like this. Okay? So I move to the left, I reflect it, and I stretch it by 3. Okay? So here my domain is all real numbers. My range is all y's, such that y is less than 0. And my horizontal asymptote did not move. There was no vertical shift up or down, so my horizontal asymptote is still y is equal to 0. Okay. So yes, if you need to, go ahead and do the step-by-step process to figure out where your new point should be. Okay, now let's go ahead and move on to some trig